Hello students, in this particular video we are going to start with our unit number 6, that is numerical integration. Now what exactly mean by numerical integration? The numerical integration is nothing but the area under the curve. Okay, so usually if this is a curve f of x where x is independent variable, x is dependent variable, we have this curve f of x. So the area under this bounded by this curve, this particular area, you can say that it is the expression of numerical integration between the limit x0 to xn. Let us say this x0 to xn is divided into n subintervals. That is why you could see that it can be written that it starts with the x0 and end at x plus nh. Now x0 can be termed as a lower limit, upper limit x0 plus nh can be termed as a b. So here we can also write this as integral f of x running from the a to b dx. This represents the area under the curve. Okay, so it is written that the given interval of integration is subdivided into large number of subintervals of equal length h, and the function tabulated at the points of the subdivision is replaced by one of the interpolating polynomial like Newton's Gregory's over each subinterval, and the integration is evaluated. So this statement is very important. So what we are doing actually, if we have these set of points, okay, so the first activity is to fit the curve between the points, okay, and the number of points you use to fit the curve will decide the degree of the curve which is being fit. So if you are using 2 points, naturally you will be able to fit the degree of curve 1, that is line. So that is called as a Simpson's rule, that is called as a trapezoidal rule. In such case you will have a trapezoid which is fitted. Okay, so you need to find the area of the trapezoid, and the rest of the area you have to neglect. Now when you use 3 points to fit this curve, or if you use the 3 point to interpolate this polynomial, then you will have to fit the curve of degree 2 with the number of points 3. So you will get a second order polynomial, and the area under that curve you need to find out. Okay, so what you need to do, what you are doing is that you are increasing the degree of the interpolating polynomial. Okay, so if you are doing this, if you are using 3 points and you are using 2 intervals, then you will get 1/3 rule, Simpson's 1/3 rule. If you are using 4 points and the degree of curve which you are using interpolating is 3, then you have to solve it with the Simpson's 3/8 rule. So Simpson's trapezoidal rule, Simpson's 1/3 rule, Simpson's 3/8 rule are totally called as a Newton's Gregory's method. Okay, so this is a basic, and one more thing which we need to remember is that whenever we use a simple trapezoidal rule using 2 points, okay, then let us say if you use trapezoidal rule 2 times and Simpson's rule 1 time, then you please note that the level of accuracy which you get by using Simpson's 1/3 rule 1 time is more than using trapezoidal rule 2 times. The level of accuracy which you get by using 3/8 rule 1 time Simpson's 3 by 8 rule one time is better than the using Simpson's 1/3 rule two times. Okay, why I am saying like that? That is because the formulae which is required for this trapezoid rule, then Simpson's 1/3 rule and Simpson's 3 by 8 rule are nothing but derived from the Newton's Gregory polynomial, interpolating polynomial. And in that polynomial, if we add more and more number of terms, the error will go on reducing. So this forms a basic of this chapter. So let us start studying Newton's course formulae. Now here what you find is that h is interval that is given by b minus a by n, and this f of x0 f of x can be written as f of x0 plus rh, where dx is equal to hdr. H is constant. So this, by changing the limits, what you can write, I is equal to h running from 0 to n f of x0 plus rh dr. F of x0 plus rh can be substituted. This is substituted by Newton's forward interpolation formula, and when you try to integrate it over r, okay, you will get this general equation. So this is the general equation which you get, and using this general equation all the Newton course formulas are derived. If you use only first three terms, then okay, if you use only first three terms up to this, okay, then you will get trapezoidal rule. When you use first four terms, like if you use this much, then you will get Simpson's 1/3. If you use all these terms, then you will get Simpson's 3 by 8, and you could find that it is going on. That means still the error is there. Okay, since you are using only certain part of this general equation and leaving the other part, the error is going to increase. Okay, so as many terms which you add, the error will go on reducing. So this is something which you should know. This is also a basic of this chapter. Okay, so let us put n is equal to 1 in the general equation. Okay, so you will have this formula, h by 2 is equal to y0 plus y1. Okay, now if you implement, or if you write in a general form, that is given by h by 2 yn minus 1 plus yn, and if you apply it multiple number of times, that is n number of times, you have to write trapezoidal rule like this way. Okay, so this is something which is required. You required a function get to be evaluated at these intervals, and from that you can find out the area under the curve using trapezoidal rule. Please remember that the area under this trapezoidal curve, okay, in the trapezoidal rule, okay, so we are fitting a straight line. Okay, so you please remember that we are fitting the straight line. So area, this is nothing but the areas of trapezium. Okay, then when we use n is equal to 2 in the general equation which we have seen, then we will get Simpson's 1/3 rule formula, that is given by this. This is a single implementation of Simpson's 1/3 rule. So when we try to implement Simpson's 1/3 rule multiple number of times, we will get this formula. Okay, so Simpson's 3 by 8 rule is given that when n is equal to 3. Okay, so here this is the formula which we get after first implementation of the Simpson's 3 by 8 rule. This is the formula, and when we implement Simpson's 3 by 8 rule multiple number of times, then we will get this formula, general form. So what you see from this is that when the number of strips are even, then number of strips, n is number of strips. So when the number of strips are even, you try to use Simpson's 1/3 formula. When the number of strips are of multiple of 3, that is odd, then you will use Simpson's 3/8 formula. And as we earlier seen that using 3/8 formula 2 times is more accurate than using 1/3 formula 4 times. Okay, because that is because of the general equation. Okay, so these are some basics of this chapter. So let us start with this first simple example. So here 0 to 1 x cube dx. So this is the function is evaluated between the interval 0 to 1 with the 5 equal parts. Okay, so that gives you h is equal to 0.2. So 1, 0, 0.2, 0.4, 0.6, 0.8 and 1 is the x. These are intervals. And the function is evaluated 0 cube, that is 0, 0.02 cube because 0.008, 0.4 cube, 0.064 likewise. Okay. And if you want to use trapezoidal rule, then how many times you are using trapezoidal rule actually? The number of strips 1, 2, 3, 4, 5. Okay, you are using 5. You are using trapezoidal rule 5 times, then you will get this formula. That is why this is y0 plus y5 and y. So how to see that? Okay, let us say how many points are that? 1, 2, 3, 4, 5. You need to plot it in like that. So it starts with the x0, y0, and it should end at xn, yn. You need to see how many number of strips we have. Okay, in this case the number of strips are 5. So this is also one simple example. In this the limits runs from pi by 4 to 3 pi by 8. We have to find using trapezoidal rule with h is equal to pi by 32, or we need to use n is equal to 6. Okay, so h is equal to pi by 32. So how to find out the number of steps? So that is equal to pi by 3 pi by 8 minus pi by 4 upon pi by 32. That will give you number of steps, that is 4. The analytical solution for this answer is 0.32443 because the function is quite simple to evaluate as an integral. So x and y, this need to be plot. It starts with pi by 4. So sine pi by 4 is 0.7071. Sine pi by 4 plus pi by 32, that is 9 pi by 32, that is the sine 9 pi by 32 is 0.7730. Likewise, you need to evaluate it at different interval. So how many strips you are using for trapezoidal? 1, 2, 3 and 4. So 4 times you need to use trapezoidal rule. So y0 plus y4 plus 2 into y1 plus y2 plus y3. So if you put the value, you will get this answer. Next, when we have to use 6 number of strips, so naturally we need to evaluate the function at 7 points. So that is why pi by 4 and 3 pi by 8. So pi by 4, 3 pi by 8 minus pi by 4 divided by 6, that will give you the h value. So that is pi by 48. So pi by 4 to 3 pi by 8 is divided in with the pi by 48 intervals. So pi by 4 first, then pi by 4 plus pi by 48, that is 13 pi by 48, then 13 pi by 48 plus pi by 48, that is 14 pi by 48. Likewise up to 18 pi by 48, that is nothing but 3 pi by 8. So at every point we need to evaluate the function, that is sine pi by 4 is 0.7071, sine 13 pi by 48 0.7518, sine of 14 pi by 48 is 0.7934. Likewise, you need to evaluate it at 4 points, so you will get 6 number of steps. And if you put the value, okay, This is the formula for trapezoidal rule. You will get this answer. Now in first case, the percentage error, you can find out error in this case because you know the analytical answer. Okay, so what it says as a conclusion, it says that thus the increase in number of steps, accuracy goes on increasing. Okay, so as many number of steps you use, the accuracy will go on increasing. So this is here is the Simpson's one-third rule. Okay, this is a code for Simpson's one-third rule. The same problem which we have solved is solved using this code. Okay, so this is the taking value taking from the user. Then this is a calculation of integration. Okay, and this is the implementation of the formula. Okay, this part. So execution, now you have to use case wise. Okay, you can use case 1 and case 2. So this is again another numerical. I'll not go in much detail into it, but you just need to see what is h. Okay, here the h is 1 by 4 and we need to use Simpson's one-third rule. Here the h is 1 by 6 and we need to use Simpson's 3 by 8 rule. And here because of this, because of the h, the number of interval are coming that you need to notice. So if you just change the function, so here what you can see is that this numerical is solved using all the three steps. Okay, that is all the three methods, that is Simpson's one-third, then Simpson's 3 by 8 and trapezoidal. So if you use Simpson's one-third, okay, it is starting from 0 to 6. Okay, so 0 to 6 using Simpson's one-third rule. Now here the point, the h size is not given, so by default it is taken as 1. Okay, so 1 2 3 4 5 6. So if you take these 6 this sizes, okay, if you use Simpson's one-third rule in this, you will get y0 plus y6 plus 4 into y1 plus y2 y3 plus y5 plus 2 into y2 plus y4. So how you can write this? This you can write as first term plus last term plus 4 into all the odd terms plus 2 into all the even terms. This is for one-third rule. And how to remember for 3 by 8 rule? For 3 by 8 rule, you can remember it like y0 plus yn, that is first term plus last term, plus 3 into all the terms except multiple of 3 plus 2 into terms which are multiple of 3. So that is a 3 by 8 rule. This is how you need to remember this. Okay, and trapezoidal rule is quite straightforward. So this is how you can remember these three formulas. And here we conclude our lecture on single integral. We have covered Simpson's one-third rule, Simpson's 3 by 8 rule and trapezoidal rule. Thank you.